Hey guys, let's take a look at number 4 on 2021 AP Chemistry for response questions. So the question says they give the equation first, 4Fe plus 3O2 turns into 2Fe2O3. And question is saying, um, a student investigated a reaction using a hand warmer represented above. A student mixes iron with the catalyst and sand in a small container. A student measures the temperature of the mixture as the reaction proceeds, and the data are given in the following table. And as you can see, as the temperature goes up, as time increases, temperature goes up. Okay. And now part A is asking the mixture has a total mass of 15 grams and specific capacity of 0.72, and calculate the amount of heat absorbed by the mixture from 0 minutes to 4 minutes. So from the equation, guys, I mean Q is how much heat has been transferred. So which is equal to mc delta T, that's MCAT equation. So the mass is 15 grams times by the specific heat, okay? And then the units cancel out. And then degrees Celsius, guys, here. So temperature changes, guys. Keep in mind, guys, always delta means final value minus initial value, okay? Final temperature at the last 4th minute, and then this initial temperature value. So if you calculate this value, the answer becomes 191.16 joules of energy. That's for the answer for part A. In part B, the question is asking, calculate the mass of iron in grams that reacted to generate this much heat. So if you are to create 191.16 joules of energy, okay, then what mass of iron must react? So you have to understand, guys, I guess they provide you with the equation and the delta H of the reaction. Okay, this is actually what? Negative 1650 kilojoules per mole. You have to understand what this value is. So this value is what? This value represents when 4 moles of iron, 3 moles of O2 react and produce 2 moles of the product, which is iron oxide, then it produces this much heat. That's the understanding, right? So now, we're looking at the iron here. So if 4 moles of iron completely react, it'll produce this much heat. So this is my equation. So if it produced 191.16 joules of energy, okay, then what would be the mass? So this is my setup. So first thing first, guys, we have a kilojoule here, we have a joule here, we got to convert to the same unit. So I convert the joules to kilojoules. So by multiplying here, I get what? I get the kilojoules. So probably it becomes 0.19116 kilojoules now. And now we got to figure out how much of energy is needed, right? How much energy was, how much of what the mass of iron is, right? So now the conversion is this conversion. So when there are 4 moles of iron, it produces 1650 kilojoules of energy. Okay, so now if I cross this out up to this point, it will get number of moles of iron needed to produce this much heat. So if I multiply this, and this portion of the equation, it will get a number of moles of iron. And now they don't need number of moles, they need the mass. So I have to multiply, I got to convert the moles of iron to the mass. So the moles will cancel out, and what I have a gram, this is a molar mass of iron. Multiply this out, you get the answer as 0.0259 grams of iron. So this is a textbook way of solving a question. Okay, do you have to solve it like this? It depends. Depends on, your skill based on how you can represent an equation. You don't have to do it like this. Okay? You can do what? So basically you can do a very simple way. You can show the answer in a slightly different way. So you can say, okay, so from the understanding, this much energy was given off for this amount of iron. So you can say that you can set up an equation where, okay, so I got 1650 kilojoules, okay, for 4 moles of iron. Okay, I'm trying to find out. Okay, so if it gave off 0.19116 kilojoules, divided by, you can say x moles of iron. It will get you the total number of moles of iron to produce this much heat. You can cross multiply, get your answer, and multiply this by what? The molar mass of iron, which is 58, and get the mass of iron. So that works. So this is a less fancier way of solving it, but still works. Cross multiply, get your answer. It's still fine. In part C, the question is asking in a second experiment, the student uses twice the mass of iron as calculated in part B, but the same mass of sand in the first experiment. Would the maximum temperature reached the second experiment be greater than, less than, or equal to the maximum temperature in the first experiment? So, I mean, if they use more iron from the equation, right? What happens? They will produce more heat because it's exothermic process. Okay, so since greater amount of iron is used, it will dissipate more heat. Okay, hence the temperature of the sand will be higher than the first experiment. That's probably what you have to kind of put, similar to what I mentioned right now. Okay, greater amount of iron, more heat gets generated.